Recorded at Get a Grip Studios in Toronto, Canada. A Get a Grip management production and in association with the Get a Grip on Lighting podcast. Financially supported by the National Association of Innovative Lighting Distributors and presented by the National Lighting Bureau, the Illuminating Engineering Society, and the International Dark Sky Association. Added to the IES's 2021 Progress Report. This is Starving for Darkness, a podcast.
This episode of Starving for Darkness is brought to you by Evluma. If you're serious about contributing to the reduction of light pollution, go to evluma.com, hover over products, and click on Dark Sky Friendly Lighting. Both the OmniMax and AreaMax lights are International Dark Sky Association certified. The warmer color temperatures of the OmniMax reduce the more easily scattered blue wavelengths, which contribute to glare and sky glow. With AreaMax lights, you get full cutoff, which also means no uplight and a significantly reduced contribution to sky glow. And all of Evluma's outdoor lighting product lines come with dimmable drivers for even more control. If your customer is looking for dark sky-friendly fixtures with energy savings while still meeting the demands of decorative lighting, look no further than Evluma. Evluma, illuminating the pursuit of dark skies.
Hello, listeners and darkness lovers. Welcome to another episode of Starving for Darkness. My name is Jane Slade, and I'm so pleased to have Andreas Jechow here today with us. Dr. Andreas Jechow is an interdisciplinary physicist with a broad expertise in photonics, the science of light. He is a light pollution researcher at the Leibniz Institute of Freshwater Ecology and Inland Fisheries in Berlin, which we will shorten to IGB throughout the show. And his main research interest is in measuring light at night and assessing its impact on ecosystems. Andy, thank you so much for coming on the show today. We're so excited to dig into your expertise. We start every episode with the same request. Would you please tell us about a dark sky experience that left you with a feeling of awe?
Yeah, so I think I have many of these moments, like being in the Arctics or in like some super remote deserts to do research. And the one that is most memorable to me is like the one which I had before I became a light pollution researcher.
Mm.
Me and my wife, we crossed Australia from east to west, went through the middle, and in the middle of Australia, there's the Simpsons Desert. And in that desert, we were probably the only people in a radius of like several hundred of kilometers. And it was super dark and it was also super quiet. So we were laying on our backs and we could hear the sand sort of like float down the dunes.
Mm.
And we were looking at this superb night sky, which is also so different to what we have in Europe. And we've never seen anything like that before in our lives. And it was just so mind-blowing. The loneliness, the stars, the darkness, and the quietness.
Yeah. Do you think that that experience led to part of the impetus to do light pollution research?
It was probably one of the pieces in that mosaic. And actually, Australia played a central role. So I moved from Berlin to Australia to do research in quantum optics, was working in a very sort of like sterile laboratory, hunting single atoms with single photons to do work on quantum computing. But we were outdoors all the time and we sort of like absorbed all the nature that we had around. And I bumped into light pollution while being there. So there's a little station near Brisbane where we lived,
Mm-hmm.
where you can learn about light pollution in the context of sea turtles.
Oh,
And what you
okay.
can do there is you can book a tour as a tourist to watch the sea turtles hatch, and then you guide them with little torches to the sea, because they won't find their way to the sea unless you help them. Right? And I found that quite impressive, that you have these animals that were programmed for millions of years to follow the brightest spot once they hatch on this lonely
Mm.
beach in Australia. And then they normally walk to the shore, not to the shore, but to sort of like the sea. But once there's light around, right, they take the
Right.
wrong way and walk all the way away from the sea. And that plus these moments in the desert, looking at the night sky, were certainly like a major thing for me moving to environmental sciences and do light pollution research.
Well, isn't it interesting? So you're saying that people can participate in uh, guiding the sea turtles to the sea with actually hand light sources to counteract the light pollution that's behind the sea turtles, drawing them away from the ocean, which I just think it's interesting from a human experience that we've overlit the background. So now we have the onus of drawing the sea turtles ourselves back to the sea. When the solution is if we would just turn the lights off, none of that would be necessary. So, you in 2015 transitioned to environmental sciences, where you apply your knowledge of light and light pollution. What was the pivotal moment that you decided to direct your studies into that direction?
Yeah, it was like there was one moment where me and my wife we traveled to this area north of Berlin where there's like this beautiful Lake Stechlin, and
Hmm.
there the IGB, the institute that I'm working for now, has the facility. It's called the Lake Lab, and it's sort of like built into the lake. It's a huge facility to study ecosystems or lake ecosystems, and I saw that facility, and I looked at the surroundings and was like, wow, I totally envy these biologists who work at
Mm.
such a beautiful place and such an interesting um, facility. And uh, by chance, just like I think a few months or a year later, there was this advertisement that these guys were looking for some expert on light that knows about measuring light, that has some knowledge on light sources. So I'm a laser physicist by training.
Mm. Hmm.
Um, so I ticked down a lot of points on this list, and the task was to build a light source for this facility to mimic sky glow. And we did build this light source, and then we did an experiment to look at how this lake ecosystem reacts to this sky glow, and this will be published in early December, the paper
Mm.
on that light source and on the some experimental backgrounds. There will be more papers on that experiment. And yeah, from that moment onwards, I really enjoyed working interdisciplinary with the biologist to sort of like bring in the knowledge on light from a different perspective into the biology and work on different topics. From aquatic to insects to bats. I've been working on a lot of topics by now, and I'm always bringing in the expertise on light.
So that's so really interesting that you got to this new location where there's this beautiful setting all around you, and it seems like it was quite in alignment with what you were already doing to bring your piece to this research. And so you were studying zooplankton, is that correct? The zooplankton
Yeah,
navigation in the
yeah.
water?
Among yeah, that was one part. I mean, in this lake experiment, we were studying the whole ecosystem. Like we were looking into like what the phytoplankton, how the phytoplankton, the algae react to light, how the zooplankton changes its movement. So it's moving
Hmm.
up and down depending on the light. So during the day, it goes to lower depths in the lake, and at night, it comes up to feed on the algae. And when there is light, it sort of like escapes the fish that we were also studying. So we were looking into fish behavior, into like zooplankton behavior, algae growth, and so on. But we were, of course, I didn't do that alone, right? So I built the light source, measured the light, and was working in a huge team of several dozens of researchers, partly from all over the world. Um, And I think what also brings us together was the passion for this topic, light pollution.
Hmm. And so zooplankton, I've read, they are considered the largest migration on the planet. On every single dusk and dawn, the zooplankton are navigating. So can you talk about what you think that the impact of light pollution upon this massive migration that happens each day might have?
Yeah, so we are so interested in the zooplankton because it has this key role in the food web. So it sits right in the
Mm.
middle. Um, and we, yeah, indeed, the zooplankton movement is sort of like the most synchronized movement around the world, right? And in every little pond and in every little water body, you have this movement, but also in the ocean. So it's like a massive synchronized movement that normally follows the sun. So like this
Mm-hmm.
daily pattern, yeah. And if there is like too if there is not enough zooplankton, for example, then algae will have more opportunity to grow. Um,
Mm-hmm.
and in the natural ecosystem, right, you have a balance. So there's some algae, there's some zooplankton, there's some fish, and then you can sort of like there's this cycle, so to say, yeah. So the zooplankton eats a bit of the algae, then some fish eat the zooplankton, but there's not like just one species eating up every single bit of the other species. And we knew that there was one study in a lake in Boston. I think you are from Boston, right? So Marian Moore did
Yes.
this SkyGlow study in Boston, and
Yes.
we saw that she could detect this movement on zooplankton when she was sort of like exposing it to SkyGlow. And one hypothesis of the study was that if we apply um, this light, then the zooplankton stays at lower depth. And one of the things that could happen is that the zooplankton community collapses, so that there is not enough
Mm.
zooplankton because they don't dare to go up to feed on the algae. Um, and and that is not only the trouble for the zooplankton, it's also the trouble for the fish that want to eat the zooplankton. Yeah. So then, if
Right.
the zooplankton community collapses, the fish community might also collapse. Plus, you might have a gigantic algae growth. Yeah, that would be like one of the extreme cases. We did not observe this in the severity as it was sort of like hypothesized by us, and
Mm-hmm.
we saw sort of like more subtle changes. Yeah, that like a specific group of zooplankton really did what we were expecting, but then another group was doing the opposite. So they actually came up. So they were confused by the light. They were not
Mm.
programmed to have light at night, and they were not trained like the species in Boston. It's an urban lake, so they were used to the sky glow to some extent. Our zooplankton in the lake where we did the experiment was always dark. It's like one of the darkest regions still in Germany. So we almost
Mm.
have a perfect night sky. We can see the Milky Way. It's super nice and super dark. And some of these zooplankton species, they just were like, they never saw light at night in that intensity that we have provided to them. And then they just went up, looking at what's going on. So they were just not programmed uh, to do their thing in this yeah, in this range that we applied light. So that was quite interesting, and it's actually so complicated that we haven't fully done the analysis. I mean, we are a big team, as I said, right? But we
Mm-hmm.
also have like complicated data. So, for example, to give you a glimpse, what we did was like we have cameras that we let up and down, and the camera
Mm-hmm.
is taking an image every 10 centimeters in 20 meters of water. And then we have some artificial intelligence algorithm that looks at like, is there zooplankton in these images, and then sorts like the zooplankton species and the numbers depending on the depth where they are. And we do that like every night at like 24 of these enclosures that we call mesocosms. Yeah, so they are 20-meter deep and
Mm-hmm.
9-meter in diameter. So it's a huge facility. So we have a huge data set, and then each of these columns that we get will sort like several species, and then somebody has to do this analysis. Like this species follows this what we call the diel vertical migration, so this pattern, right? But the others does the opposite, or does it not, right? So you can see that during the night, species should go up, so they should sit up here.
Mm-hmm.
Some go down, some go up. It's relatively complicated. However, we repeated this in Berlin in the river, and there we could see the clear pattern that the zooplankton actually escapes the light. So at bridges, illuminated bridges, we saw this pattern that the zooplankton goes down also during the night when the bridge is illuminated, and it comes up when the bridge is not illuminated.
Mm.
So I hope that answers some part of your question.
Oh, yes. You know, there's nothing to replace darkness. And what you're telling me is only reiterating that point because there might be some instances where species may try to do accordingly, regardless of there's light at night. So you observed some zooplankton species that were still mustering the strength to come to the surface of the water in spite of light. And yet then you're also seeing there's other species that won't do it. So I always say there's nothing to replace darkness, that while there may be some solutions in fine tuning the wavelengths of light to reduce impact, that we can't eradicate darkness. So you're only proving my own hypothesis about that. Um, and then, also what you're making me think about when you research the river. I recently heard a beautiful philosophical quote, though, that you cannot swim in the same river twice because it's a moving, living thing. And so I just, I think about these aquatic systems. And also, this is kind of out there, but when I think about zooplankton being the largest migration on the planet, it also makes me think about how the skin is the largest organ, which is kind of surprisingly. But so we have this sort of skin over our planet, and we're shining light not only around cities with 120-mile radii that are cascading outward, but also we have tons of boat traffic that's pocketed all over the world, and we're really changing the skin of our planet and its ability to churn nutrients. And I had also read that scientists have likened the nightly or daily migration of zooplankton to the surface of waters as a jet propulsion that churns the nutrients of waters across the globe. So we're really almost changing the skin of our fabric of our earth by changing how these nutrients are exchanged, and so it's a very small organism with an amazing amount of impact on food chains.
Yes, yes. I mean, when it comes down to protection of animals, there is something that researchers just recently found that whenever like um, humans find a species kind of cute or attractive or something like that, right? And there's like this big effort to protect, say,
Sea
the
turtles.
pandas, yeah, yeah,
Yeah,
or the sea turtles, right? There's no
yeah.
big empathy for something like zooplankton, right? It's just
Mm-mm.
there, and the importance is quite sort of like underrepresented in the overall media and so on, right? And um, yeah, so we researched zooplankton in this big facility in the river, and inspired by some colleagues from Norway, Jørgen Berge, who's there's also like a movie about I forgot the name about the movie. But there's a filmmaker that followed like Jürgen during the Arctic night on a ship, and they measure like what the zooplankton actually does in the super dark polar night. Um,
Mm.
and the researchers from Norway, they found out several things. So first, this migration in polar night adjusts to the moon. So instead
Mm.
of following the sun the sun cycle, right? So then the zooplankton starts to follow the lunar cycle. And I guess Jürgen is also like kind of a cool person. So he termed the name werewolf zooplankton because it's sort of like following the full moon pattern.
Yeah.
And he found out several things. Like, for example, you mentioned chips, yeah. So he found out that his own research vessel was disturbing his measurements on the zooplankton. So when they had lights on the ship, whatever they measured was wrong. So they had to like sort of like emerge themselves into the super darkness, right? Take like this ship into like switch off all the lights and then repeat the measurements to get really the right signal from what the zooplankton does in its migration. And it is so crazy, right? It's like an ecosystem, like so far remote from humanity, from where people live, because there's like boat traffic or ship traffic, right? The zooplankton still is affected by light pollution, and it's like probably one of the darkest habitats for a longer period of time, like the polar night in winter. And you think there's nothing living out there, right? It feels so harsh and so unhuman, but then you can still detect that these species react out there. And we did an experiment in Finland on a frozen lake to look at like if like the zooplankton in the lake. So there's like a layer of snow, there's a layer of ice, and then there's the water body. And it's in the middle of winter, minus 25 degrees Celsius. And we saw a little like dip in the zooplankton movement. It's very much buried in the noise. So we were there with some Russians from Lake Baikal, and they said, yeah, they can repeat this experiment, and they did. Like, so then at Lake Baikal, they can drive like a gigantic truck on this frozen lake. It has like 2 or 3 meters of ice, and then they were shining a normal floodlight you can buy just in a store. That was what we were buying in Finland, and did some experiments out there on the frozen lake. And they repeated the experiment in Lake Baikal, and we can clearly see the zooplankton in Lake Baikal being affected by this floodlight down to 50 meters. So it's like
50
several
meters
meters of
below
ice,
the
50 meters below. It's like several meters of ice and then 50 meters. And the zooplankton basically immediately just goes away to the side because they cannot
so
go
sad.
fast enough down. They just go all the way to
They
the side.
scatter.
And they just escape the light, and they don't mind the direction so much, but they just escape the beam of light basically immediately. So we see it like on a sub-second information. Hey,
This is Ferdinand.
hey Ferdinand.
That's my cat.
Um, and it heard something like lakes and fish, and so right, it's then getting attracted.
Yes,
Um,
exactly.
Yeah, down to 50 meters, we could see that the zooplankton signal is affected, or like the distribution. And then when we switch, or the colleagues in Russia, they switch the lights off again, right? Then the zooplankton slowly comes back. So you see, like immediately they go away, and slowly
Yeah.
when the light is off, they come back. Yeah, and that was something that we are just writing up and going to publish. And yeah, and actually
Well,
coming back to the first question, that
yeah.
moment in Finland was probably the second most awe moment that I had with dark skies. Right, it
Oh.
was like a huge lake, so we had to drive 20 minutes with the snowmobile on that lake, and then we were there, snowy desert, and then there came the aurora, right? And that's like then this other awe moment when you are in the middle of nowhere in the cold, and then the northern lights sort of like paint the sky really nicely, and you see the crazy light pollution from all around, even up north at the polar circle where we did this experiment.
Firstly, I think it's funny that you used a floodlight, only because I've recently been commenting that I find it funny that we have a whole type of lighting in the lighting industry that is named after an environmental disaster of too much water. And so it just goes to show how unintentionally we're using light to flood our earth with light with no understanding of its impact. And actually, the way that you describe the movement of the zooplankton is as if a bomb went off and people scattered, and then they slowly come back to the environment where the bomb went off. So this beam or bomb of light that's coming down through the water, it's also not surprising that it's 50 meters below, because we know that one fixture can pollute up to 120 miles away. So here you have this light coming down and creating a very you can tell the zooplankton don't want to be there. It's an unharmonious environment for them. And so it just also that you mentioned that they zooplankton at the poles follow a lunar cycle. That doesn't surprise me, since the sun has such a large absence during parts of the year, that they would adopt a lunar cycle of light. And the way that humans are lighting the planet, it's like we've removed the conductor, the main conductor, the Rosetta Stone, our natural daylight cycle, and now we just have this crazy, uh, incongruent light that's coming and means nothing. It's garble to wildlife. So I think that's all very interesting to hear about this impact. And also, I want to say that when you commented that the scientists realized that they had to turn the lights off of their ship to not impact their research, and you also commented that when you first visited the lake north of Berlin and this research facility, that you were felt so lucky that you could potentially take part in such a beautiful environment and also do your research, that I would say we're better scientists when we're communing with nature, when we're in alignment, when we're turning the lights out for ourselves too, and also experiencing what we want to study. So, would you agree or disagree that the beautiful environment also helps to elevate the scientific thinking?
So that's an interesting thinking. I mean, um, what certainly uh, helps is that whenever I'm there, so I live near Berlin, so in a more urbanized surrounding. So I go to
Mhm.
this place every now and then and do research of the night sky, the brightness of the night sky. Whenever I'm there, I feel like uh, coming down, right? It's like really like, you have all the busyness of the city and everything. And when you're there, then you can focus much better on certain thoughts and stuff, right? So
Mhm.
so when
Yeah.
I'm out there on the lake at night, I'm mostly alone, and then I do like my measurements with cameras and yeah, like measurement devices, yeah. And yeah, then I have also time to think, right? While I'm just doing obtaining these measurements, I can think, right? And it's not scientific, but what I feel all the time when I'm there is like that. Whenever I come back to the city, right, and people that only live in cities and never go to places like that, they are missing out. I mean, that's certainly something. Um, uh, I got used to work in the darkness. I got used to adapt to the darkness. We were trying out things like how long does it take for us to dark adapt to be able to walk in the forest next to that lake and all that kind of things, right? While whenever I'm in the city, people would switch on lights. Whenever it's dark, people use their phones, use sort of like flashlights and stuff like that, right? To whatever. It's just kind of a habit of normality, and we totally forget that there are species that are sort of like living in the darkness. And I always have this analogy with sound. Imagine you would
Hmm.
put up like a huge noise all of the sudden, right? And or like a very high frequency tone or anything, right? People would find that annoying. And if you are
Yeah.
totally dark adapted, then switching on your phone will be like, oh, this is way too bright, right? In the morning, you will sometimes have this, right? My kids don't like it when I switch on the lights in the morning, things like that. But when you are adjusted to this brightness, you think it's normal. And, and adding a little bit doesn't matter. So we humans tend to uh, make it a little bit brighter and brighter and brighter, which you also see in satellite imagery. And yeah, that's certainly not good, right? We can think of ourselves that we humans have a huge capability, a visual capability. So probably if we lower all the lights in our environment, we could probably still move around, navigate, and feel safe and actually be safe, um,
Hmm.
without flooding. I like that thinking of. I never thought about the floodlight in a way like this, but I like that. Without
It recently
flooding the
came to me.
environment. Yeah, it's so obvious that you
Yeah.
don't think about it, right? It's yeah, yeah. That's one thing. I wouldn't go that far. That like I wouldn't connect it to science that much, right? I mean, there are like environmental scientists, there are other scientists, and I don't know if like somebody that produces vaccines should go to a dark area. I don't know. It seems a bit far fetched to me. Certainly, as a uh, I would recommend that to everyone. I wouldn't exclusively recommend it to scientists, right? To
Right.
every now and then go to like a pristine area, and also enjoy the night sky, and yeah, enjoy the darkness. I think the darkness is something that we attach to so many bad things, but darkness isn't necessarily something really bad, right? And also, a night sky, not light polluted night sky, is not darkness, right? It's a confusion that we often do. It's just wrong.
It's very bright and is kind of what you're saying, that it's actually a vast amount of natural light in the natural darkness.
It's not necessarily very bright, but I mean, if you are in an open place and you have the Milky Way up, and you wait, say, 20 minutes or so, most people will be able to walk around. I mean, not at the edge of the Grand Canyon or something like that, right? But say you are near a beach or something, right? Then you can probably see enough to not fall into the sea. Um, and that is something that most people living in urban areas just don't experience, and that they also don't want to experience because they are so much used to using artificial light, right? So we really
Mm.
have disconnected because I mean, our ancestors, they were walking around during full moon, and they were also probably walking around during clear nights when there was no moon, as long as they could sort of like uh, yeah, so they could see some threat or something, right? They wouldn't walk to the super dark forest because that would have scared them too much. Um, but if you think of us today, it's just so normal. People go out of their home, it's bright inside. Like in my place right now, if I go
Hmm.
outside, I don't see anything. If it would be like at that lake we're talking about all the time, right? I would have to wait at least 2 minutes or so to see something. So then it's inconvenient, and you switch on the lights. But theoretically, I could just dim my home lights and then make the transition from indoor to outdoor much easier with much less light in the outdoors and the ability to move around.
Right. So I am going to push back on what you said a little bit earlier, and I think you'll probably agree with me anyway, but that um, it's not scientific that someone could have a different set of thinking at the lake versus, say, in an urban environment. And I actually think that it is absolutely scientific, that we just haven't backed it up with science. But this is something that I write a lot about, which is that we have changed how we perceive the world around us by only experiencing brightly lit environments. And we lock our hormones into these stagnantly lit environments so that we're not changing our hormonal landscape. And that I think, like you said, you feel that people are missing out when they are not able to experience that lake environment. And I think that we're actually changing our thought patterns massively across the planet. And that when we actually allow natural darkness to set, so a very different experience happens, and a very different way of perceiving our bodies, minds, and the world around us happens. And since most people are not taking that, even I myself, I have an iPhone, I live in an urban environment. I don't have a fireplace. I don't have a lot of access to natural light sources. So I think we have removed an entire way of perceiving and also meditating through our daily experiences. And I think that science will soon show that these other ways of perceiving are actually very valuable and critical ways to approach problem solving, and that we've removed that as a tool from our perception. Any thoughts about that?
I mean, uh, so I said that we disconnect, right? And I
Mhm.
also said that whenever I'm out there, I can focus much better, right? Um, it's just probably not for everyone, and
Yeah.
so I guess there is also science on like this lack of proper circadian rhythms and so on is like impacting our cap- capabilities, right? On many different ways, right? So um, it's it's just a matter of like practicality at the moment, right? That
Mhm.
it's people live in urban environments. Like how do you move them in a I said the vaccinations, right? So you have to develop a vaccination. You're under time pressure, right? And then somebody comes and is like, bing, 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 it's your dark sky time. You have
Yep.
to go for 2 weeks to this dark sky place. Um, it seems difficult at right now, right? So however, it might be the right thing to do. So I mean, scientists go on retreats. Scientists do sabbaticals, right? And whenever you talk to this elderly professor about like the most productive time recently, it will be like, when I did my sabbatical. So yeah. Um, so sometimes in general, taking time off from what you do will accelerate your yeah, probably your innovations and so your creativity. Um, and I totally agree that humanity has too much disconnected from the natural night sky, from the natural night. Uh,
Mhm.
from like most people wouldn't know what moon phase it is, right? Here in an urban environment, while
Right.
people living in villages, they know that. They can see that. They sort of like experience that, right? And I found that quite cool that my daughter, when she was 4, she was telling um, some adults when the adults told her that like the moon is up every night, right? She told this is wrong. Like the moon is also up during the day because she did the observation on her own. I didn't tell her anything about it, right? It was just like whenever we saw the moon, I said, I looked up, there's the moon um, several times, and then I forgot about it. But she kept on observing. And when an adult said, the moon is up every night, the moon rises and you have to go to bed, and then she's like, this is wrong. The moon is up during the day every now and then, and it's just it comes up every night at a different time. And this was an observation she made on her own because she paid
Yeah.
attention. we don't pay attention anymore, right? We don't care about the moon so much. We care about our iPhones. We care about what was in the news. We care about whatever, like uh, yeah, the normal things that we do, right? We don't look at the night sky, particularly in the urban environment. And but we work on changing that, right? So we
Right.
not only communicate our findings on zooplankton. I'm also working on a project about street lighting, where we want to implement new types of street lighting. I work on a project that is about protection of bats, where we want to change the lighting around bat communities and all this kind of stuff. So
Yes, so with the bat lighting, are you fine-tuning combinations of wavelengths that could also reduce impact on bats while maintaining human visibility with lights? What is the research that you're doing there?
what we are doing there is very applied. So we go to a place where bats are, like for example
Mhm.
some old churches, and then they will live in the tower. And the thing that I do is like I quantify the light environment. So I have a little drone, so I can fly up to this tower
Oh, wow.
and then measure the light in the bat's eye view, right? I also go up into the tower and measure with a camera out of the uh, space where the bats fly out. Plus, I use the drone to then look around what could be disturbing for the bats. Um, we don't do research on specific wavelengths there, right? It's more like we
Mm.
go to this church, for example, then we quantify the lights, and then we say this light is bad and that light needs to be replaced, and this kind of stuff. And we monitor the bad behavior in the meantime. So I work with a colleague that has an infrared camera where he can see how the bats fly out of this church. And then we do this before when there is light pollution around this bat community. And then we change the lights. So right now I'm planning changing the lights at certain places like a church, a town hall, and so on. And in the next year, we will look if this has changed the behavior of the bats. So we know when they fly out. So
Mhm.
we might see that they fly out earlier or later. And we want to see if they fly on a different path when they fly out. So right now
Interest
we have one building where they come out and they fly over the roof, and then there's light, and then they make this turn and they fly
Wow.
all the way to they change their direction. And then we want to change the lights just in front of that building and see if the bats then fly out straight, or if the light wasn't actually the one that was disturbing them. Um, yeah, but the wavelength, sort of like susceptibility, is not at the focus of these studies. There are some studies from colleagues where they found some found that green light is good, others found that red light is good, right? This is again a little bit with the zooplankton, which I said in the beginning. Some species are like this, and some species are like that. Um,
Yeah.
right now, for the dark sky communities, for example, this dark sky movement, right? All the blue wavelengths are more or less found to be not so great for the environment, for the night sky observations, and so on. So people move to more towards more red lights. For some species of bats, my colleagues told me it's actually bad to have then this kind of light, and it would be better to have green lights. So, it, yeah, but you cannot, of course, run around and change all the lights to green lights. But something that we work on is then that you have sort of like a tailored approach around such communities. Not in the project where I'm working on right now, but some other colleagues, they try then to investigate if a super tailored spectrum of light
Yeah.
is actually better for the bats or actually not, right? yeah, but
I've long
such
believed that's the solution is finding some combinations of wavelengths that are less harmful that still allow for human visibility. I know there are some case studies happening in the Netherlands where they have installed bat-friendly lights that seem to not really impact the species. And I this is where I feel that LEDs have been the curse, but that they could potentially be the cure because there's no other light source that we've been able to fine tune wavelengths in such a way. So that is my great hope for wildlife friendly lighting in the future. But with the huge asterisk that there's nothing to replace natural darkness because each species responds differently to light. So we don't want to over design to one species and then have unintended consequences in others. But I still think that there's probably a middle ground there that can be accomplished. And it's really interesting just to see what you're studying, which is the general movement of a bat species in relation to avoiding light. I think that's important for people to see and feel that response in a species to light. Just as you're saying with the zooplankton scattering underneath the surface of the water. I think more stories like that help to build the collective consciousness uh, and the understanding of light, that it does have an impact, because currently the zeitgeist is not aware of how light impacts humans or even wildlife. And as you're saying, it's very intuitive to say sound, an annoying sound is uh, is something that you shouldn't have on through the night, but it's not intuitive for light. And something I just recently learned, which is that the human ear can't even hear all of the range of sound that comes from our own voices. So it just goes to show that with these sensory experiences, humans have, maybe we're not the most we're very smart, we're very intelligent, but our senses are not what wildlife senses are. They're much, much more sensitive to various stimulations. So we kind of don't even really have a clear view of the impact we're creating with light at night or with sound. I would venture to say that there's probably sounds that we haven't realized we're creating that are causing great harm for wildlife on the planet. So I I also want to touch back and say something before, which you said that there's a practicality issue in urban environments and how we advocate for darkness, and I think that's absolutely true. And that your colleague said his best, most productive time was sabbatical, and I think that that's because, and I feel the same way too. Sometimes when it's before 9 or after 5, I have such a sense of relief that I won't be interrupted, that I won't get an email that's going to, divert an hour from the task that I was trying to accomplish. And I think there's something about the light driven information that's constantly coming through that makes us want to pack our bags and go to a retreat and cut it off. Um, and that there's a practicality issue of making that happen on a daily basis. But I think that we would be um, better humans, better designers, better scientists if we could practically build that back into a nightly experience. And that's what we once had, um, but we are no longer taking it. So,
well.
yeah,
Um, yeah, I would like to comment on that, right? I mean,
yeah,
I
please
would say
do.
right now this is not practical, but we should not give up, right? Because
Agreed.
um, as you said, we're just careless with light at night. We just use a lot of it. Um, and if we can land at this sweet spot where we have light at night so that the people can do their things and are in a safe environment and so on, right? But at the same time, reduce the unnecessary emissions into the environment and into the night sky. Um, I think there's huge potential to reduce the light pollution so much that if you live in an urban environment, it will only be like maybe a half an hour drive or something like that to experience this night sky. Like Berlin is not too bad. Like most people would find Berlin super dark, right?
Hmm.
But still, Berlin is quite safe compared to other cities in the world, not talking about US cities, right? Um, but this place, which is one of the darkest areas, among the darkest places in Germany, almost near perfect night sky, is only an hour drive from the city center of Berlin.
Wow. If I
Um,
had that in
and
Boston, I would be driving there all the time. There's no place that you can escape
yeah,
to.
and we also have an IDA dark sky park that is also like just one hour, 1.5 hour from the center of Berlin, and that's sort of like a certified dark sky place. Um, and so Berlin is not too bad for what reason soever, right? I mean, this is not in the focus of my research. This is probably, um, but I map the sky glow around Berlin, and I drive around at night and do camera measurements and so on, and then I can see like how quickly the sky glow, the enhanced night sky brightness from light scattered in the atmosphere is getting better and better. And around Berlin, it's not too bad. So even from my house, I can see the Milky Way. It's not great, but it's there. Um, and if we would reduce or if we would replace all the fixtures in Berlin that are still radiating into the sky, or limit really the light uh, emissions to the places where we really need the light. You would be surprised that if we don't change the intensity at all, it would be even better than how it is now. How much I don't know, but I would
Mhm.
make a guess that you can probably at least cut this emission into half very easily. Right? It will not be cheap, but from a technological or physics point of view, it's not magic. Yeah. Um, uh, However, it's a huge effort to convince the politicians, to convince the people
Yeah.
to do this. Um, and once you get there, once you have these, like there are even several dark sky cities around the world where they have the light fixtures sort of like improved, make dark sky friendly, right? Um,
Hmm.
and if you think this is only half of the story, right? This is about the emissions upwards. This is not talking about if you have a street and you want to light that street, that you sort of like also light everything left and right of it, right? The urban park next to it and so on, right? So this is only the upward emission. And we work also on this light in the environment. So say we have a street that's this wide,
Hmm.
then the streetlights right now they radiate in all the directions like this. So uh, you have light on the wall of the houses left and right. You
Right.
have light on the trees and all this kind of stuff, right? But only like 20% of the light hits the street. So if you can narrow down the light just on that street, you would save energy and you would sort of like totally reduce light emission into the environment and in people's houses,
Yep.
um, and so on, right? And we have to get there. And once we get there, then we will be surprised, I would say, because then we can also reduce probably the intensity, and then we can probably also just take an hour drive from Boston to see the Milky Way.
Yeah. And that design scenario, which is very common to see streetlights actually pushing light into windows. It's also creating a cyclical effect where humans no longer realize they're not experiencing darkness. And then when they feel darkness, it's scary, it's uncertain. Our our pupils have grown weak to be able to expand to that large circular circumference. So it's an unsettling thing, but we're actually kind of taking this exercise out of most people's common experiences. And I totally agree with you that there's a sweet spot that we have not found yet. And that if we can carve away some of the egregious lighting and then start to be really intentional, that it would be just so much more beautiful of an experience. And that I think by then also creating potentially dark sky experiences that are only an hour away from major cities, you can start to begin to sell the idea and reconnect people to natural darkness and all its value, because people just don't know anymore. They've totally, totally forgotten. So, is there anything that you'd like to leave us with your upcoming research?
Um, yeah, we maybe I can just say one more last thing about
Yeah.
this streetlight project. Yeah, so we talked about the zooplankton, we talked about the bats, and now we work on like insect-friendly street lighting. So the idea behind this is what I just outlined, that we only want to light up really the street or the footpath or the cyclist path where you need the light. Then we
Mhm.
also want to hide sort of like the light fixture from animals, not insects only, but animals living in the surroundings. Because
Mhm.
right now we are quite used to that. Say we are next to a village, outside of a village. It's pretty dark, and we can see the village from several kilometers because the light fixtures emit a lot of light in the horizontal direction. It then travels for hundreds of meters, and such light fixtures will attract, for example, insects and might disturb other animals, birds, migrating birds, for example. And we are right now working with companies on shielding these lights, but extremely
Mm.
shielding these lights so that you cannot see them, say, if you're standing 10 meters away from that street. And it's technologically possible, and we are investigating how this is impacting insect populations. We will set up this in January, February at a field site that we have in this dark sky park, the Westhaveland near
Hmm.
Berlin. Um, and then later we will also bring this into villages. For example, the village with the beautiful lake that I'm working on. And there we will also, because we want to find the sweet spot, we will also then talk to the people and ask them how they like or not like the slide. Because at the end of the
Love
day,
that.
it's not only like a technical, right? I could be just the engineer, physicist, say like this is where the light has to go, and ignore what the people want, right? But we also have this citizen science approach where we
Mhm.
talk to the people, where we um, yeah get their feelings about the new light. Is the shielding too extreme? Is the color temperature like this? Is that okay or is that not okay? Right? Because humans are creatures of habit.
Yeah.
So you are used to certain things, right? And if you are used for like decades that this you have this lamp that radiates in all the directions, and that the village is like looking as it is looking, right? And then we come and we just illuminate the street and cut off all the lights on the buildings. People might be offended, or like they might not like it, right? So we also want to get their opinions, right? And then from all this information, from like how this is hopefully better for the environment, the insects, plus how the feelings of safety and the aesthetic feelings of the people are. Right? Then we want to distill a future streetlight from this experiment, and that's something that we have on the in the pipeline that we are working on right now, and I'm excited about that research as well.
I am too, and I think it's fantastic that you're trying to integrate the people's opinion because it is critical. And I think when we talk about darkness, it does trigger people's sense of alarm that there might be safety issues coming in that they would be worried about. So I think when I remember once an elder architect said to me when I was working in a design firm, she said, I'll never forget it. She actually gave me this Ganesha right here. But she said, you have to bring it all up at once, the whole project. So each piece has to come up together. So that's exactly what you're doing. You're bringing the human component up, and you're also addressing, which is a massive ecological problem, which is the decline of insects on the planet. And we're seeing that happen all over. I think light is certainly a factor. So I'm so pleased to know that you're addressing that issue because it will affect everything. There's 10 quintillion insects on the planet at any given time. They outweigh humans 70 to 1. And so the way that we're illuminating our planet is just using the adage moth to a flame. And we're actually seeing this insect apocalypse. So the fact that you're designing light sources that might not be able to be seen from an insect from further away could potentially really reduce impact. So that sounds like a very, very exciting. I'm so pleased to hear about that work on the horizon. And it's been an absolute pleasure to talk to you today, Andy. Thank you so much for coming on the show and sharing your research. Please come back again. We'd love to hear what you're working on. So thank you so much.
Thank you.
Look no further for dark sky friendly products than Evluma. Since its first product launch, Evluma has carried one or more International Dark Sky Association certified models. If your customer cares about light pollution, suggest the OmniMax with shielding or the AreaMax with full cutoff to reduce uplight and glare. Evluma, illuminating the pursuit of darkness.